live already, so I think we can start. Welcome today's session. We wanted to propose this birth of a feather session because there's been a gap between the first sessions in the interest group on chemistry research data, and there has been many developments which we would like to publicize today, and also continue working on maybe towards the definition or the setting up of a working group in the publishing of chemical research data. We have three presentations today. The first one is from Ian Bruno. He is talking to us about developments in the definition of standards and with some examples, particularly from the Cambridge Crystallography data center. Then we have another presentation from Brian Matthews. He will be talking about an example of using FAIR data, which he has been working on at STFC, and this is mainly to do with the use of Jupyter notebooks and FAIR data repositories. And finally, I will be presenting a use case in determining the fairness of the research data objects that we carried on a subset, a very specific set of data from Catalysis Hub publications. So those are the three things. And afterwards, we will have a long, a 40 minutes or so conversation talking about these the issues we think, and having time for your questions and answers. So if you have you can see the Q&A panel and the chat panel. Please try to put your questions there in the Q&A. Questions to any of the speakers, and then we can retake them at the end during the discussions part of the session. So without further ado, let's start with Ian's presentation. Ian?
We're not hearing you, Ian.
We have we can see your slides, but we cannot hear anything from you. You will see many, the screen divided in many small bits. If you want, you can click on the expand the screen button and see the presentation, make the presentation larger, so that that way you can your voice is off.
I just note, if you want the session is being recorded, if you want it to capture the slides well, if other people turn off their cameras and microphones, that way the session recording will just capture the slides. Otherwise, it will capture all of us.
Okay. Yes, please. Then everybody turn off your camera so that we can have the larger presentation while and maybe we can turn them back on. If you can use also turn off your microphones so that we only listen to Ian while he presents. Thank you. Oh.
But Ian, you have to have your microphone on.
And if the mic is on, but you're on mute, Maybe that's the issue. I don't know.
Yeah, we can't hear you, Ian. I think there's been a suggestion in the chat to go to Brian while we're resolving this. You may need to make sure you selected the right audio source, Ian. Again, if you have multiple microphones.
Brian, why don't you go ahead and do your presentation?
Yes, we can leave Ian's for later.
Yes, okay, I will do that. So, I'm afraid I think it would have been a bit of. I'm not going to talk about notebooks. I'm going to talk a bit about a different thing, about what we do in large-scale around data publication and data, and fair data management. So, apologies if there was a. It's probably going to be a little bit different to what was advertised, but I'm sure this will be an interesting talk nevertheless. Let's see if I can get this to share. Let's have a look. Here we go. And if I press play, I think we're all slightly new to this platform. No. Well, that's probably showing my slides but in presenter mode rather than display mode, I think. If I swap. Can you see now? Can you see my slides in?
Brian.
In the middle.
Yes, it's there.
Right, that's the opening slide with full screen, I hope. Okay, so yeah, I'm going to talk about the FAIR experiment in the context of facility science. So a little bit about where I come from. So I'm Brian Matthews. I'm a group leader in the Scientific Computing Department at the Science and Technology Facilities Council, which is an institution in the UK which, amongst other things, including research funding, funds and operates large-scale analytic facilities. Particularly, we operate a neutron source for a neutron spallation source and a diamond synchrotron light source called ISIS and Diamond, and also various other sources. Particularly, we have a laser facility with high-powered lasers, which is also used for particular analytic science. And I'm not going to go into the details about how these operate, but essentially these are major sources of experimental capability for doing experiments in physical sciences, particularly chemistry and materials, supporting large number of user groups around the UK and around the world. So I've been involved in data management for these large-scale facilities for a number of years, and also involved in a number of different activities to sort of explore how we then sort of expand on that and make it more accessible to the scientific user community, including the European Open Science Cloud project, where I was involved in projects such as EOS Pilot, and also currently I'm lead on a project called Expands, which I'll go into later, lead on fair data, we're package lead on fair data, and I also lead a service in the UK called the Physical Science Data Service, which is about providing data to UK scientists. But I'll mostly concentrate on Expands in this talk. So this is a picture of our campus, where we're based near Oxford. So I don't think I need to go into the detail about what FAIR means to this audience. I think we have an audience that's very well versed in this area. So I'm going into details, but it gives us a practical breakdown on how to enable data sharing and reuse. With very general criteria, it's not quite the same as open, but it's about being open about data. And this gives us a sort of recommendations in that. Those recommendations gives us a framework. That's really quite a useful thing. It's rather than saying, oh, be open, it's actually giving a sort of recipe, a framework that we can then apply, and that's increasingly being reflected in funder policies, and particularly in the EOSC. However, it does lead us to sort of particular issues and questions, such as particularly how should researchers working in a particular discipline change what they do to make the data fair, to make the work fair. And then, more generally, and then sort of how does that take it to an institutional level? Then, what should the institutions to do in their policies, their processes, their support, their funding to support that, to encourage that fair science. So all I'm going to look at is a little bit about that. And we're working in an ecosystem. So a discipline will have typically a very complicated ecosystem of different actors and stakeholders, all of which are data suppliers or data consumers. So, for example, in a physical science ecosystem, we're typically looking at sort of big facilities like ours, and institutes and hubs, cross-institutional initiatives. We got laboratory scale research facilities, so a particular crystallography institute which is supporting either one university or a number of universities providing specialist instruments or imaging or NMR. Computational science facilities, so people writing codes, typically in community projects which last a long time.
Sorry. Yes, could you try to adjust your microphone a little bit, because there is a constant buzzing every time you speak?
Oh, okay, sorry about that. I don't know what's causing that. I will adjust. So I'll turn the volume down a bit, perhaps. Maybe less feedback. Is that any better?
Yeah, it's not feedback so much as a tinny sound, almost like a rattling in a case. It's difficult to tell whether it's just a bad connection even or something.
Well, I'll try all my connections. Yes, I'm getting it a bit too. I'm not sure what I can do about that. That's new. That is, yeah, I'm sorry, I'm not sure what I can do about that at the moment. Let's try disconnecting and connecting again.
Okay, you just continue and see. We can make out. It's a bit hard to make out what you're saying. Did you mute? Brian?
Yeah, if it changes his audio source, you may have to manually tell it to switch.
Can you hear us, Brian? Okay. I think he did. That happens when you refresh. Sometimes you cannot see the...
Agree. I see the session if Ian's back.
I cannot see him. in the list of participants.
Hello.
Brian, we can hear you. Yeah, that's really clear.
I think that's better. Yeah, much better.
Sorry, I disconnected and then reconnected.
Yeah, that worked.
Is that a lot better?
Yes, yes, much better.
Sorry about that.
No problem.
I will try to resume in that case.
Yes,
that one. Now it's not showing the screen.
We can see your script. We can see the slide, Brian.
Oh, you can. Oh, I can't see. Okay.
Yeah, you just see a black square saying publishing.
I'm just seeing a box in my. Yes, I'm just seeing a black square. Yes.
Everybody else sees your slide.
I think this is, I guess it's first try of the technology, and it's all a bit glitchy. But we'll get used to it. Okay. So yeah, what was it? Computational sciences. Yes. So groups writing codes and sharing codes. Research institutions and labs with individual research institutions and the data they're collecting and the repositories they're providing, and and data resources and collections, particularly open data sources, licensed data sources from commercial companies, or and also journals. We can't get journals in this mix. So a very mixed infrastructure. And if we need to help guide fair science, we really want all those actors to support FAIR as much as possible. So I'm going to focus now from the example of what we're doing on the photon neutron large scale facilities. We work right across physical sciences, chemistry, materials, and also in life sciences, engineering, sciences, and a wide area of other disciplines. So why facilities is interesting? Well, I mean, as facilities, a major engine for chemical and materials science. We're an area where kind of big science meets the long tail, if you like, where big central institutions can support lots and lots of different individuals working in small teams. So it makes a very interesting interaction of that broad support, and that makes us quite influential and influenced by many sciences. But it does bring in individual heads, and we can hopefully set some good practices and work with the community on setting standards. Right. So I'm working focusing on one project called Expands, which is also working with a parallel project called PANOSC, which are between them representing a large number of the institutions around Europe. There are 10 facilities involved in the Expand project. There's another 6 sort of different ones larger ones in PANOSC. And yeah, for historical reasons, there's 2 projects, but working very closely together. And the work package I'm leading particularly is work package 2, which is called Enabling Fair Data, and there's a similar work package in PANOSC, looking at data policies and stewardship, and we're working towards fair data for environmental facilities. What are we going to do to improve what we're doing? So what we're doing is reviewing and recommending policies, practices, and standards, which gives us the best practices for fair data for photon neutron sources. So kind of how I see it, this project and sort of in general is are doing some steps towards fair facilities or fair science in general. And I think there's sort of 4 things we need to do. Firstly, we need to set policies, the guidelines on what we're working to, with that commitment to fair, saying what the support of the facility is, clarifying what the ownership is, saying what the expectations on users are. We want to provide guidelines to build on that, how we might support FAIR, how we might use persistent identifiers, what metadata standards should we be using, what implementation strategies should we be doing to support FAIR through the life cycle, and also FAIR metrics, how we're going to measure our fairness. And then sort of the implementation part, what tools we're going to be providing, how we're going to do storage, how we're going to do cataloging, publishing, how we're going to integrate data analysis tools, how we're going to use VREs, how we're going to use electronic notebooks, etc. And finally, this should lead us to the FAIR experiment. So how do we conduct, bring it all together to how do we conduct a particular experiment fairly? And this, I think, is an important role for data management planning here. So the facility staff, the users, all know what they need to do and what they're contributing to build that FAIR data package at the end, and FAIR science package. And so that's deeply embedded into the processes of what we do. And I think, this works for facilities, but I think this can be seen as a guideline for all science. Facilities have a reasonably well-defined workflow in that people come with us with a proposal. This goes through various peer review processes and gets approval. And then there's sort of preparation period where there's scheduling and training happens. People come to visit, or they would in non-COVID time come to visit, run an experiment or an instrument, generate data, usually with come with a set of samples, generates data that then gets stored. There's some initial data reduction processes typically, which clean up data. Then there's data analysis, data publication. So we're working within a fairly the details may differ very much from experiment to experiment, and we've kind of gone into that. But there's a general workflow that we work with. And we want to be fair every step. I think that's the important thing here. We want to be able to collect information about what we do at every step along the way. So during the proposal, you can collect information about what the experiment is about, who's doing it, what's it for, who's funded it. And then as you go through scheduling, you may collect more information about the sample, what you're doing, what preparatory work have you done during the experiment. You've got the information about the run itself, its parameters, its values, its data fields. Storage, then you locate where you're actually locating it and what things about its format, size, structure. And then as you go through the analysis process, you want to add more parameters about the software, about data inputs and outputs, and about the provenance, about where it's come from. And finally, where it's going to reside in journals, and give us the results, the analysis and citations, again, provenance. And so I'm going to have to hurry here, I think. In facilities, I guess, have a slightly privileged situation that we tend to have well-defined information systems supporting a lot is underneath. So you can have places where data can be collected, but what you need to do is then, of course, link that all together, collect it together, connect it together, and keep it for the long term. So collect, connect, curate. So back to this. So what we try and do is data cataloging. I've been involved for some years with a system called ICAT for more than 10, 12 years now, where we do this systematically for our experiments. We use some of our experiments, and it works very well for the sort of in-house parts, the proposal through to the experiment, storage, initial data reduction stages. Tends to lose it then because we lose control. The analysis steps are very important, clearly, for the whole picture of what's gone on in the experiment, but they tend to happen much more ad hoc, tend to happen outside the organization, so they get rather decoupled. So there's a limit to what we can do, even though we really, really want to get that information as part of the data package given the context of that final publication. So this gives us kind of a realistic aim, so what we're looking at in our data policy, and we've used some new data policy recommendations just recently out of Expands and indeed PANOSC. And the key point here is that data should be fair when it leaves the facility. I mean, we should do everything we can as a facility provider that it makes sure it is fair at that point. I mean, at that point, we can't guarantee anything. We can encourage, we can recommend, but we can't make guarantees. So we want to make the recommendations sufficiently rich that we give that make sure that it's in a good state when it leaves the facility. And it's obviously there are a number of arguments what that really means, because there are different types of data as we go through a process, from the raw data off the instrument through various different reductions or transformations or processed or data. So where are actually our boundary lies of our responsibility is a bit arguable and may change from experiment to experiment. Okay, it's good. So to quickly whiz through some of these, the guidelines we're looking at on these steps, and thanks to Alejandra Gonzalez-Beltran who produced some of these slides. The findability part. So as I already mentioned, we're looking at a data catalog. We're using ICAT as another one. We're using quite a lot of facilities called SciCat, very similar in some respects. And this gives us that searchable index catalog for our data, give it back to the users and indeed the wider community. And we've got a well-established data model underneath that to support that, support the metadata, so we can find information about
Brian, could you speed up a little bit?
Yeah, sure. I will speed up very, very much so because I've got too many slides. Accessibility. We want, I won't go into that. Again, we're looking at authentication, but looking at DOIs, and we're looking at how we fit into an infrastructure of DOI, system identifiers. Particularly interested in extending our range to things like organizations, instruments, and samples. So things like Inchi's, RIDs, things becoming ISGN, IGNs comes in here. And I'm going to probably then skip through quite fast now, I think. Okay, so yeah, and then interoperability. We need to provide a structure of different levels of information about our data from the system. What systems you're using, what syntax you're using, data formats, how is that structured into data schemas, and then finally semantics with our ontologies. And we're looking at all these areas. There's a well-known format called Nexus that we use a good deal for that, and about standardizing that and actually making that more shareable into ontologies as part of the work. So that's a slide on that. I won't go into that. We are doing some more work on ontologies, though. There's a gap, if you like, between the metadata for the data holdings and what you might call domain ontologies. So like things like the European materials modeling ontology. And that's what we're trying to fill. So information about the experimental life cycle, about the instruments and techniques, and about the experimental parameters we're looking. So we're looking at putting in place some new ontologies to support instruments and techniques and some and the experimental parameters. I won't go into reusability apart from say, using. It's important to use common community standards in this area. And sort of one final area, going back to this slide, we want to combine information across these different areas, give this full rich picture of a discipline of the information ecosystem back to the users. So we're looking at linking together those resources using those PIDs, giving that sort of rich view of the information space. And we've done some experiments in this in the context of the FAIR project. So this is an example of looking at, what is it looking at? It's looking at experiments and users on two different sources from one institution and looking at their common links and also links through to theses and indeed information about chemicals under investigation from ChemSpider. So trying to bring that bigger picture back. And I think at that point I will stop actually. What we're doing is looking at guidelines for making data fair, data available, what sufficient information is usable, and back to the user community as fairness. What we provide, we think, is an example of where we might drive towards fair data, and contributing from our point of view the policies, tools, guidelines, and practices for fair data. And thank you, and apologies for the technical hitches, which meant I had to sort of rush at the end. So thank you.
if you can hold your questions to the later, we can move on. We can try now, Ian, to see if we can see your presentation.
First of all, can you hear me?
Yes, we can hear you.
Step one, wrong box. Screen share next. Application window, share. Can you see my PowerPoint?
Yes, now we see your PowerPoint.
And can you see it in presentation mode?
Not yet.
Oh,
Clicked on the start presentation.
I have just done that, yeah.
Yeah, you may need to choose either the particular window or a particular screen.
I will quickly do that. Screen sharing. Okay, let's do the entire screen because that's probably the safest option, isn't it? And I've only got one screen here, so it's not controversial. Can you see my presentation?
Now it's there. Yes,
excellent.
it's there.
Thank you very much, and thank you for everybody else for bearing with the technical hitches, but also thank you for Abraham for convening this. As he noted at the start, it's been probably a couple of years since
Ryan, can you turn off your screen? Thank you. Thanks. Sorry.
Sorry?
Yeah, no, keep going. Yes.
Okay. Yeah. As Abraham noted at the start, it's probably been a couple of years since we've had a dedicated session on chemistry at the RDA. So we're grateful to him for convening that. It's not to say that there hasn't been work going on in other places that is relevant to FAIR and chemistry, and I'm hoping to give you an overview of that throughout this presentation. But I'm coming to you from the Cambridge Crystallographic Data Centre, which Brian glossed over on a slide there, talking about sort of data publication in crystallography. And before getting into the sort of chemistry aspects, we just wanted to do a very quick overview of how things work in crystallography, particularly through the lens of the Cambridge Structural Database. This is a collection of over 1 million crystal structures, which are variously associated with articles from over 1,500 journals, representing about 200 publishers. We get over 55,000 data sets deposited a year from researchers across 80 countries. We want to make sure these are published in time alongside any articles they might be associated with. We also give an option for people to publish independently of an article, and currently that's around 10% of what we're receiving. And then we enrich those data sets to ensure that they're discoverable and reusable across domains, and the knowledge derived from that gets applied across industry and academia. So how do we do all that? I think we can reduce this down to quite a small number of technical enablers, workflow enablers, and social enablers. And I'm just going to very quickly go through some of what those are in the next few slides. Let's think about a crystallography experiment, and this actually might apply to various experiments in chemistry and possibly beyond, with a few sort of specific variations. But you might have a sample, and that will have a source, such as how it was made, how it's crystallized, what properties it might have. You'll then have some equipment like a diffractometer that you might use for your experiment, and there's facets of that you might be interested in, like what model it is, its configuration, the conditions under which it was running. Coming out of all this is data, and we'll have raw data, processed data, derived data, specific artifacts of that might be relevant to a domain. We'll have software that's used to process that data with the parameters and configuration used for that. And then finally, we got various forms in which the end result might be published, whether part of an article or in a repository or a database or something like that. Now, crystallography is blessed with this standard called CIF, which actually allows you to semantically capture pretty much all of those facets. Not all of them, but pretty much all of them. And it's not just a data format, which defines a particular syntax. Underpinning CIF is definitions of data items that are defined in a separate dictionary item. So that, yeah, if you've got a chemical formula weight, and yeah, you should know that it's in Daltons and not in some other units. And one of the key things, I think, to this, I mean, CIF underpins the success of data publishing in crystallography, but as important is the fact that it has been adopted across the sort of research cycle by the people who write the software that spits out the data, the repositories who are accepting deposition of this, and the publishers who are requiring that. It also has that support from the International Union of Crystallography, making it sort of like an endorsed community standard. So it's great to have that sort of metadata and data standards, but I think workflow is important here. And one part of here is guiding the researcher through the deposition process. And this is where an organization such as CCDC can help. When someone's got a CIF, we can make sure that it's the right syntax. We can also take advantage of other services to provide some form of validation. We can make sure that we're capturing other pieces of metadata that might not be captured, like who did the experiment and whether there's any other additional properties that perhaps hadn't been captured in the CIF but are caught somewhere else. And that's what we aim to do with our deposition workflow, enable researchers to easily follow these sort of recommendations, provide reliable data, and get their data out there and published. But then downstream from that, we need to think about how this all joins up with the sort of publication. And I said we had quite a large number of publishers that were associated with. There's probably actually only 5, 6, or 7 that account for the majority of structures. And over the years, we've developed various different workflows with them to make sure that when an article that has a data set associated with is published, the data set gets published as well. And then we can also go sort of further upstream and make sure that if data sets are associated with a manuscript, we capture that association early and can make sure the data is available for peer review. And one of the sort of challenges of this is that currently we have as many different workflows as we have relationships with publishers. One of those is use Scholix, which is a start because that hopes to that sort of provides a foundation for standardizing things. But I think this is an area where there's opportunity for general improvement across sort of like the research data publication ecosystem. Important part of this is identifiers. We assign DOIs to our data sets, but as important is the fact that behind that with DataCite is a metadata registry that allows others to come along and discover the metadata, create links from other resources, include it in resources such as the data citation index and what have you. So that very quickly was a sort of overview, I think, of some of the key enablers of publishing data in crystallography. And I think these are enablers of fair data publication. I think having your data and your metadata standards and your persistent identifiers goes a long way to addressing many of the facets of FAIR. But you do need those workflows and those sort of social enablers to sort of glue this all together. So that's crystallography. And now I want to have a look a little bit more at what's going on in the area of chemistry. Now, it's easy to get the impression that chemists don't share data. And this was taken from an article that's published in 2015 that showed a proportion of articles sharing original data in chemistry, right down the bottom there. But interestingly, there was another chart in this which showed the proportion of articles that refer to original data. And in chemistry, that is one of the highest in looking across disciplines. And I think it's wrong to say that chemists don't share data. This slide here shows a study done by Ye and Joanna Thielen at the University of Michigan. And it shows different types of data type and where they appear either in articles or in supporting information. It also shows that most of that information is in a PDF or static images. So chemists do share data, but primarily in supporting information and in a PDF, and not in ways that result in data that are fair. This is an excerpt from the State of Open Data Report 2018. You've got a small little circle for chemistry, which perhaps reflects the engagement that the chemistry community was having with FAIR at that time. And if you look at the green sector, very few chemists were familiar with FAIR in the first place. So there's an education piece there as much as there is an enablement piece. Now, this is a study that was done a few years back by Vincent Scalfani from, I forget which university. It begins with A. He's in the US. I apologize, Vin. Here he looked across the top at different chemistry data types, and then down the side started looking at the policies of different chemistry journals. And you get this color coding coming out of ranging from data types that are required in a repository through to those not required. Within the middle, those that are required or maybe optional in a manuscript. And if we look at the green color coded pieces here, it represents crystallography and structural biology. The question was sort of, where do we go next if we want to try and improve things in sort of like chemistry data types? And you've kind of got this required in manuscript sort of merging here for spectra. And so spectra has been a sort of reasonable focus of activities that have been taking place in discussions about FAIR and chemistry. And there's two particular sort of workshops that I reference here. One in 2018, which was done in conjunction with the BoF FAIR Chemistry Implementation Network, had a strand that was looking in particular interoperable criteria for spectroscopic data exchange. The following year, there was a workshop dedicated to fair publishing of structures and spectra. And what that was looking at more was the sort of workflow piece of this and the guidelines that you might need to put across to just encourage people to make their data available in a more machine readable way. And out of this came a pilot that the ACS publications have been running across 2 journals, where the editors of those journals wrote a letter and said, hey guys, it's time to start sharing your data in a machine readable way. And we're going to encourage you to do this. We're going to accept it. And further than that, the ACS provided a tool that would help people package up the data that they had. And the idea here behind this was just to try something and just see what appetite there was out in the wider community for people to do this. And over a 1-year period, there's been around 200 submissions. Now, I don't know the percentage, but I was on a call yesterday with someone from the ACS, and they implied it would be very small if you compare it to the number of spectra that are being published across chemistry in a week, never mind a month probably. But that's okay, because you know, it's a start, and there will have been a time when there were only 200 CIFs deposited and the rest was being sort of dragged out of the literature manually by abstractors. So it's a start. But it's also provided us with some insight as well that we can use in other projects. And one of these is one that's sort of looking at developing a fair metadata sort of profile for associating with spectroscopic data. And the aim of this project is to come up with metadata specifications that don't worry so much about the format in which the data is stored, but make sure that we've got the fields that we need to describe the contents of that data collection, and importantly, associate the chemical structures that might come of that and analyses relating to that. This is just one of many projects that are going on within IUPAC that speak to the FAIR agenda. Others that I draw attention to are ones that are looking to come up with machine representations of critically evaluated data, such as atomic weights, radical polymerization kinetics. I said that as if I knew what it was. I don't. But solubility as well. So there's lots of work that goes on to IUPAC to come up with critically evaluated data points, and so it's not just the value itself, but it's all the various sort of conditions and caveats that you might have on that data that you need to catch. And the other thing that's been going on is developing guidance for best practice in actually disseminating data, and there's a project within IUPAC to do that. But I think it's also worth drawing attention to the ACS Guide to Scholarly Communication, the sort of most recent version of which was recently published. And this has a whole section now on data sharing. This is all part of trying to make the wider chemistry community aware of what the opportunities are for them. Moving back to IUPAC, many chemists will know IUPAC for being the people who define the right way to name things, but they also define the sort of terminologies that describe the science of chemistry through various colored books. And then we have the Gold Book, which is an aggregation of all the above terminologies there. And this has had an online presence for quite a number of years now. But recently, and Stuart Chalk, who's been on the call, deserves almost pretty much all the credit for this, has been going through a significant overhaul. And so we now have a version of this that has an API, a license, provenance, DOIs for the terms. It's being used to link data. Very much a FAIR asset in itself, as well as an asset that can help enable FAIR. Need to give mention to Inchi, which Ryan mentioned as well. And it's for those that don't know this, if you've got 2 different but equivalent representations of a chemical structure, Inchi will come up with one string that will allow these to be considered the same. And this is quite important as a means for being able to link between different resources, but also as something that you might include in your metadata to describe the chemical structure that's been involved in the chemistry experiment that you've been doing. Inchi isn't yet complete. There's lots of areas where there's room, where there's a need to develop it, and there's opportunity to develop it. So there's sort of various different projects taking place within the Inchi enterprise. And if you're interested, there's a plenary session on Monday next week, which will bring you up to date with all the outputs of these various working groups. We also need to recognize that sort of the wider sort of infrastructure surrounding Inchi needs to grow as well. And so at the moment, the Inchi Trust is recruiting for a technical director to help move the sort of maintenance and development this onto a more sustainable and collaborative footing, and a marketing and outreach director to help promote use of that in wider communities. So these are those sort of technical workflow and social enablers that are currently work in progress within the chemistry community. And hopefully that's given you a flavor for what's going on. I think just very quickly at the end here, I just wanted to sort of pull out a couple of slides we've used in the past to sort of like try and articulate the transition that we feel we need to make. Moving away from this sort of analog model where people do an experiment, they get their data out, gets packaged into supporting information or buried away in an article, and it's only really good for humans. That's important, let's not forget that. But what we really want to move to is a sort of model where, as people do experiments, the data is being collected together into a package that might get put into a domain repository, and it's that the article links to, and it's from there that it's available for both machine analysis and for humans. So that is my presentation.
Okay, thank you, Ian. That was very good. So just to remind you, if you have questions or issues with the material, please post it on the Q&A part of the is to the right of your screen. You have chat, and then you have a Q&A button. So if you want to post any questions to the speakers, put them there, and then we can come back during the discussion. So the next thing is my short presentation. I also have a presentation which is on the an experiment, an analysis of the data management at Cardiff University at the Catalysis hub. So this is, can you see my presentation? Yes. Okay. So we'll just go on to. Just let me make it bigger. Yes.
Abraham, we can see your. That's we can now see it in. Yeah. Okay. Now I think we've got it now. Yeah. Yes.
Yeah. You are seeing the presentation. Okay. So we started with the same aim of making data fair, but this is in the context of the Catalysis data infrastructure, which is new infrastructure that we are designing and developing for publishing the research data that is produced within the Catalysis hub. We work from the same place as Brian, so the STFC at the research complex at Harwell, and we work with ICES, with Diamond, and with the Central Laser Facility, as well as with the Rosalind Franklin Institute, which is a new facility. And the Catalysis data infrastructure, we see it as a specialized repository for the data that we produce. So, but not so much as a repository, but a catalog that links to the resources and the data. So we have a prototype application that will go live soon. We have a temporary view of this infrastructure, and that allows us to see many indicators which are interesting for the research community and also for the funding institutions, like how many publications and how many citations do we have from these publications, the countries where these publications originated, the institutions that participate, and so on. And this is in the 8 years or so of the first years of life of the Catalysis Hub, which also started in 2013. So moving forward, we would like to have more indicators because at the moment, from data from Crossref, we can get up to 30 indicators, which are something like this. I think you can see my browser now, and this is the type of things that we are doing, like pulling out how many publications from team, the most recent publication, or top publishing researchers, the names and the publications that have published, the most cited publications. So we update citation counts from Crossref, and we add up these citations, and then we can say, offer researchers who are the top most cited researchers. So these are indicators. But we also started collecting data about how they publish data. And for instance, how many data objects they have referenced in their publications. And we have links to the data set itself. So, and also starting to get some insights into the composition of these data sets, like the type of information, like crystallographic information, or compressed files, or images, or even videos, because some of the researchers share their data in videos as well. So in data sets, for instance, we can see also the repositories where these data objects are deposited. So these are the different institutions, and I think this is the one, e-data or data for, yeah. So we can drill down and actually click on the links and see the information on the repository. So that's the main goal of this data infrastructure, to link between publications and data sets and researchers, and even get more insights from the data. So, and in the future, even enable greater use of data. So determine the type of data stored, not only the type of data file, but extracting information about which components are analyzed, which elements, the chemical formulas, and reference values, and available spectra, for instance. So, but we wanted to see how fair is the data that's been shared. So we see that we have that more than 300 data objects, but we don't know, are they all really as fair as possible, or can this be improved? So we created a rapid scoring system, which is very ad hoc, but we assign some values to the data that we have, and we try to say, okay, if the object is referenced, if it gets 5 points on findability, but if a special access is required, we deduct 1 point. If the location process is too complex, it's not straightforward, we deduct another point. If there is a referencing error, like the link points to something that does not exist, we deduct some extra points. If the reference only says you should contact authors and there is no ID, then we deduct 4 points. So that's for findability. Accessibility is something similar. We can say the object is accessible if it is referenced, and we also deduct points in a similar fashion to the findability. And then we also created two scoring tables for interoperability and reusability. This only give 3 points maximum each. The basic score is 1 point if the object is available on the web, independent of the format. 2 points if it is available on a structured format, and 3 points if it's available in a non-proprietary open format. So those are the scores, and the reusability is the object is available on an open license, it gets 1 point. It has a persistent and unique identifier, it gets an extra point, and it's linked to other data objects. So it gets, including the research article. So that's the main, the greatest score of reusability. And out of 400 references, we have 542 data objects potentially. And of these, majority, 95% get a score above 10. So they are really closer to the FAIR standard. Most of them could be made fair. So, and we also think that, but this is, the main issue is the type of data they are sharing. And as Ian pointed on his presentation, most of the data is supplementary data, or which is shared in PDFs form. With that means they are it's not really easy to reuse or interoperate with this data. We compare the trends in the publishing of data from the beginning of the Catalysis Hub until 2020, at least. And there is an increase in the number of publications. This is the accumulated, and this is the yearly number of articles published. In this part, the file count is the blue part, the total, and the orange part is the portion of the total that cites some data. So we also seen an increase on the rate of publishing some or referencing some data in addition to the data in the article itself. And this is when we start to see the shape of this big iceberg of data, all the data that's behind these the published results. And this so we see that the supplementary data tends to be unstructured data, and there is a correlation almost here with the type of data structuring and the type of role of the data. So most of the data is unstructured data, and most of the data is only supplementary data, not raw data or original supporting data. So, and then we devised, we were trying to propose a method to improve on this. So we were looking at the verification process. This is from BoF FAIR. The BoF FAIR process has 7 steps, which says you have to retrieve the data, you have to analyze and inspect the data. If the data is structured and can be easily aligned with a semantic model, then it passes to the next part. So having these 7 points, we also score 1 point to our objects and saying, can we carry out all these activities and then verify or make our data fair? And most of the objects are in the range from 6 to 7, so they can be verified. And the only ones that are not, don't achieve the 7 points is mostly because they are not structured. But if we relax that requirement, we could say all of them can be verified to some extent. And we see that this is only a fraction of the total data that we could make available. because in the last 2 years, the rate of that, or the number of data objects referenced per publication is about 3.2. So if all the publications had this same average number of published data, we would be talking about 1,150 objects in total. And this is just a very conservative estimate, because normally the data sets are a complete data set is much larger than that. And as Brian showed with his presentation, there is a lot of support within the facilities for the publishing of research data. I mean, even the ICAT system has been in use for a long time in the facilities, and it's already being used to support the publishing data. For instance, ICES regularly publishes data after the embargo period of 3 years, and the data management policies for Diamond, it has been reissued in 2020, and it states now that also after the embargo period, that Diamond light source data is going to be made publicly available. So we came out with sort of recommendations for publishers and authors on how to make your data fairer. So, for instance, adding supplementary and supporting data to the article, taking care that all your data is referenced, using your ORCID ID, getting your ORCID ID so that your data can be unambiguously linked to you, adding DOIs to the digital identifiers to all data objects if possible, and annotating the data objects with meaningful metadata. So which is also something that Ian touched by the end of his presentation. So this would be for publishers, and for authors. Well, just be consistent in mentioning published data. Sometimes there is a disconnect between the published data and the article, and the data exists and without having a link to the published results to the article. So that's something that we are trying to amend. So those are the recommendations that we are saying, and the main idea was that to work towards a working group within RDA focused on these issues and of making data fairer and making it more visible for all the stakeholders. So one of the issues is the backlog. So having activities like the one we did at Catalysis Hub to rescue all the current data and make it a continuous activity to annotate, identify, and link data and link data to publications, the creation and promotion of standards, making sure that new data is born fair, and the promotion of repositories, and which is the role of specialized indexes like the one we are proposing for the Catalysis data interface. So, yeah. And in terms of education, we also continuously promote the use of data management practices. In fact, we are having a data management virtual workshop, the first one of its kind for the Catalysis community, this is going to be from the 10th to the 11th of June, and these are a small list of some of the presenters that have agreed to participate with us. Yep, I think that's all for my part. Thanks for your attention, and stop sharing. Yes. So we are back in the discussion, and Stuart is going to be moderating the discussion.
Abraham, you have a couple of questions in the chat.
Yes.
Sorry, questions in the Q&A, I'm sorry.
Mm-hmm.
Did you want to answer those first?
Yes, I would go ahead. So the first one is there a way that a researcher can get a badge to advertise the fact that they have published FAIR data on the Catalysis hub? Not at the moment, but we could implement it. That the purpose of making the interface public is precisely that, to get feedback, because at the moment we are at the point where we have done a lot of development and proposed many ways to look at the data. So this would be used something that could be very interesting to do, to attach a badge to say this is a FAIR publisher. For instance, we already have like this league table saying, oh, these are the authors with most publications, and these are the authors that are published a lot of data. So it's just another good idea maybe to implement these badges. Thanks for the question. And then how do we define a data object? Okay, in this one, we wanted to make a distinction between dataset and data object, because a dataset we felt that it was a bit restrictive, and because we found that there are many types of data objects that people is sharing. So they are sharing documents, structured data, images, videos, and all this is better encompassed within the concept of data object, rather than with the concepts of data sets. So that's why we switch between using data set to use a data object. And this is maybe a trend that we've seen even in the RD8, so moving towards talking about data objects more than data sets.
Thank you, Abraham. Brian, did you want to answer the question about Diamond that just came in the Q&A? I guess, are you still on, Brian?
Yes.
Yes.
So the question is about, right, not providing Diamond, not providing DOIs for raw data sets. Is that an active decision maybe, or is that something?
So I don't want to go through a long history here, but partly the way that I don't particularly want to go into the details about Diamond and the decisions they've made there, but okay. They have taken a quite, in some respects, a quite conservative approach. I mean, they do see that they've historically, I mean, I guess it all comes down to ownership as well. I mean, they do very much see them as providing a service to users. And therefore, the data, in that sense, belongs to the users, and users can decide to do what, and historically has control over it. And therefore, it hasn't necessarily always left it to quite obviously quite rightly in many respects to as a user's decision about whether to do publication. Now, other institutions have taken a different approach. I mean, the ISIS facility we work with takes the approach that it will publish data, but that's generated on facility anyway. I mean, it takes the approach that it's a publicly funded data set, and therefore should be, with suitable embargoes and caveats, made available as soon as possible. So I would say it's a difference in approach, and it sort of that decision on how to best serve your community. I don't think is in Diamond's data policy is changing and is likely to move to a more fair policy. I mean, certainly we've had a lot of discussions with them recently in our recent revisions of data policy, and using Zenodo or something has been a bit of an expedient. But I mean, I don't think it's necessarily the long-term solution there, as my personal opinion. So I think it's partly a difference of opinion of how to best serve the communities. But I mean, I think we are looking in projects like Expands and Panosc to try and produce a more harmonized approach, but there'll be inevitably institutional and national differences in that in organizations like ours.
I guess a follow-up question to that is, in a sense, does Diamond kind of think of itself as a repository? That's kind of a key question relative to.
So Diamond sees itself. I think an institution like Diamond would see its primary purpose is to serve its user community and give the best results to that user community and do what the user community wants to do best. So it's repository, and it does archive. It does at least archive all its data. I mean, it has a very, very large data deposits, data archives, but again, the primary target of that is the person who collected it. So it's not necessarily been there for data sharing. Now, as I said, that is something that maybe is something that they've been looking at for quite a long time about how to change. But I mean, part of the issue there is there's quite a big legacy, and what to do with that legacy is proving difficult. I mean, a lot of the time, just keeping up with data rates can be quite a struggle.
Oh, I can imagine. I'm sure it's producing huge amounts of data.
Yes.
Well, unfortunately, we are basically out of time. Obviously, we had the technical issues and stuff. Given that there might well be, those of you on this call that still either have questions or comments or want to feed into.
Stuart, are you sure we're out of time?
Are you sure we're out of time? I thought we had till 1:45.
Yeah.
Oh, I'm sorry. I don't know why I had 7:30 in my brain. Okay.
Probably because it's early in the morning for you.
Yeah, that's right. I've only just had my coffee, so that's my. Okay, so let me revise that and say, let's open up the floor for discussion. Obviously, I think one of the focal points of this is what are the things that, in a sense, chemistry needs to do relative to data sets to enable FAIR, and maybe not necessarily enable FAIR just in the digital sense, but enable FAIR in the sociological sense. And so, any comments from the RDA community would be appreciated, and obviously would nominally feed into a potential working group. And open your mics to comment, I think would be appropriate here. Not hearing anything, so No comments from the attendees?
Maybe not, I think.
I actually can't see a list of attendees right at this moment, so is there a way to see how many attendees there are in this situation?
You can click on the icon that under the screen. It has like 2 persons, and you can, if you click there, you can see how many people signed in to the session. So
okay,
yeah, there is some people there, but the problem is if they left, the avatars and the names stay there. So maybe we are not sure if they are still here.
okay.
Okay, yeah, we had a discussion here with John about the policy from Diamond, and he said that it was not correct. So the policy just changed from April last year, and the embargo period, the first embargo periods would end about in 3 years' time. So from 2023, they should start. They have the option to start publishing in an open access basis. It's not what they are doing at the moment. It's not the operational procedure as what Brian was explaining. That at the moment they have not even implemented the repositories, but it's in the planning. I am in contact, for instance, with Nitya Raman, and she moved from Catalysis Hub to Diamond, and they are looking into this creation of the repositories. They are starting, I think, with reference values for spectroscopy data. I think for XAS data.
Thank you, Abraham. Does anybody have any comments? What are the things, if you're dealing with chemistry, that you feel are missing based off of your needs and or the discussion that was just had?
So I think it would be interesting to have more than one microphone.
There.
It's running on 2 computers at the same time because I've got some tech problems. So I'm in more in the area of imaging, mass spec, imaging, infrared, imaging, Raman. And although there are some ontologies that handle the generic aspects of the of a spectrum, they don't really handle a lot of the sample prep aspects, and they tend to stop at the point of a generic experiment, not an imaging experiment, microscopy type experiment. I'm not really sure quite where to go to find either better ontologies, should we say, or more suitable ontologies, because I find it difficult to find. It's quite easy to find stuff in biology, but it's quite difficult to find them in other domains. So having some better central repository for identifying where to go and look for things would be very useful, I think.
And specifically there, you're talking about repository
to change look. Sound now, can't you?
Sorry, say again. Sorry. So you're looking for a repository to be able to know where to go to get ontological definitions of things. Is that what I heard?
Yes, kind of. So there are some already out there. So there's the chemical methods ontology. And there are a couple of others, but they don't quite cover the space that I feel that we need. So, I would like to be able to describe something accurately rather than generically, but I'm not sure where to find more accurate ontologies for sort of a wider space. I don't know where to look for them. I find them in the biology world. You've got the biofoundry, for example, but there doesn't seem to be something that's covering all of the chemical space.
So I guess a question that follows from that is, can we definitively know whether or not something exists? Because it may be that you can't find it because it doesn't exist, but what confidence can we have that it's not out there somewhere? And I suppose ontology is not so familiar with our space, but I get the impression a lot of effort has been gone into organizing the ontologies within biology so you can have more confidence. If it's not there, it's probably because it doesn't exist. Can we have that same confidence in chemistry? What do we need to get there?
Mhm.
Yeah, I think indexing important topic. But unfortunately, the flip side of that, and in particular your specific need, Alex, is that in the sense it's the domain experts in that particular area that are kind of like the ones that know that area the best, and as a consequence, in a sense, would be the ones to mint an ontology to extend other ontologies. And so it's, it's one of those catch-22s, really. If you don't do it yourself, there's probably not anybody else that's going to do it for you. Now, in a sense, maybe though, this is something that nominally might need to be directed at IUPAC, because in a general sense, right, IUPAC is, quote, responsible for the whole area of chemistry, and there are movements towards trying to do ontological stuff within IUPAC, but of course the IUPAC structure is, let's just say, it moves a little slowly, and this is not something that is going to, this is something that's needed now. It's not something that's needed 3 years from now. So I put a link in the chat there, which is to EBI's ontology lookup service, which is the kind of equivalent to OntoB, which is used in the biology space. I will write this down as a point that we need to, in a sense, come up with some kind of resource to help those in the chemistry space find ontological definitions of things that are appropriate for chemistry.
Yeah. Even if it's a place where we can suggest a term, this is something I would like. Does anyone know where I can find it?
Okay.
Yeah. A mailing list, or something. And the idea that, I agree that the idea that the domain expert is very knowledgeable in their field, but then they know nothing about ontologies. They don't even know what the word means, never mind how to build one. And then you've got ontologists who don't have specialism in the domain. Is there a way of doing some sort of speed dating?
This is the crux, right? We need
people together.
We need to get ontologists working with chemists to be able to make this happen. Yes. And in a general sense, I mean, that is a lot, I think, of what is actually going on right now relative to data and FAIR is, there's obviously a focal point on trying to provide basically information scientists, information or data stewards to be able to help researchers actually, get their data fair. And in some fashion, that part of that responsibility is to help them decide if that's what they need. So, there's a lot of opportunities here to be able to fill space, and I'm writing it down right now in my notes here. Where would I find it? Any other comments about needs?
Yeah, I had a sort of a thought. So at the moment, it seems like there aren't really the tools to kind of facilitate FAIR in an easy manner. So a lot of the stuff people are doing with FAIR in chemistry now. Are you getting feedback?
It was like repeating.
Nicole. Is it working now? I did hear a bit, but I only have one microphone. So let me.
Somebody else.
Maybe mute your microphone, Stuart.
Okay, can you Here, is that okay now?
I think it's okay.
Okay, cool. So a lot of the stuff people are doing with FAIR at the moment seems it's a lot of effort that they have to go through in order to try and make their chemistry data fair. And I think one of the things that might potentially be something to get more people involved is about how, like, illustrating the real benefits of FAIR, like how it will like help them. And it is a little bit of a chicken and egg thing, because unless you have lots of FAIR data, also I apologize, there's a train, you can't really show the full benefits of what you could do with all the FAIR data until you have the FAIR data there. But I think it's really important to maybe show those benefits and what potentially FAIR data could benefit people in order to encourage them to actually put in that effort that's required. The other side of it is obviously we need the tools to making it FAIR easier, so that people don't have to put in quite so much effort, because they don't need extra things in their workflow in order to get their data out there. It's already complicated enough as it is.
For that comment, Nicola. Yes, I think it's probably clear to a lot of people that if we could have some kind of system, software, whatever, that could kind of, in a sense, help the development and the generation of chemistry data to be fair, where the researcher doesn't necessarily have to kind of know that's happening, that would be the best scenario, right? That you have some interface where you kind of put in your research data. So this is like a digital research notebook, and then under the hood, it takes care of as much as possible in terms of organizing the data, organizing and assigning metadata, and then also packaging it up in whatever the appropriate format is and stuff like that. And yes, that's the utopian Apple product that doesn't yet exist. So,
to some extent, I like the way ISIS works. The ISIS facility already has this in place, and they made their version of ICAT. Part of it is publicly available. And after the embargo period, you can go and search for the data and look at the proposal, the results, and there is a lot of resources there. So I think that's, and it's kind of what Brian was talking about with this ecosystem of in the STFC facilities.
Yeah, can I comment on that? I mean, I find one of the big problems with what I was trying to say is that the later you leave it, the more work you have put in. I hesitate to use this term in this audience, but I have used the term sort of data entropy. The longer you leave it, the less fair things get. So you have to put more energy in at the end. That's why getting it built into a process. The FAIR experiment. You don't start being fair later on. You start at the beginning, build it into your tools. So that's doing a lot of the work behind the scenes for you. And one of the things I didn't quite get to in my talk was data management plans, seen as not something that funders tell you to do to stick on the shelf, but actually actively guide you through a process to build a FAIR data package at the end. So they're actually doing some work for you. Part of that is actually telling other people what they need to do to contribute to your FAIR data package. So yeah, I mean, just to say that there's, I think we need to look at the whole life cycle of experimental to make sure we're not leaving ourselves with a big retrofitting job at the end to make things fair.
Exactly. Okay, now we are actually at the end of our session, unlike what I said before. So thanks everybody for attending. Abraham, did you want to comment on the additional version of this that was going to be on Friday, I believe?
Yes, there is a repeat session on this Friday. Is from 6 to 7 UK time, but it's just to allow people from other regions to be able to participate, or if people wants to come and catch up with us. we will be showing, the first part will be just a video of the presentations or repeat presentations, and then we will just try to have a conversation afterwards. So if you want to invite any colleagues or come back with any more questions, there will be another opportunity. And we are open for comments all the time. If you want to come off to any of us, we would really appreciate your feedback. And that's all. Thank you.
Yes,
Thank you.
Thank everybody for attending today.
Okay.
Appreciate it.
Thanks a lot. Bye.
Bye.